what we did was we took the square and we created a 45, 45, 90 right triangle by just drawing in one of the diagonals. Now, do we know the sides of this square? No. What do we use in math when we don't know something?
They are
X. We use a variable. Okay? Now, if this side of the triangle, if this side of the square was X, what do we know about the length of every side of the square? It's X, right?
So it's us.
Okay. So, correct. Instead of calling it a 45, 45, 90 right triangle, what could I call it? I could call it an isosceles right triangle. That would be another name for it. Good. So, I know that both the legs of this triangle are X because it's part of this square. Now, what I'm going to figure out is the length of the hypotenuse. Okay, when we have a right triangle, what can we use to find missing sides? Pythagorean theorem. Okay, so let's all remember Pythagorean theorem. A squared plus B squared equals C squared. So anytime you have two sides of a right triangle, you can use Pythagorean theorem to find the third. Anytime you have two. And you'll have to do that on the worksheet I leave you tomorrow. There'll be some where you just use Pythagorean theorem.
Is it just right triangles?
Just right triangles, yes. Okay? So, here are my two legs, x and x. So I'm going to say x squared plus x squared equals the hypotenuse squared. Can I call it h? Okay, we'll call it h for hypotenuse. All right. So x squared plus x squared is how many? There are two of them, aren't there? And if I wanted to solve for the hypotenuse, what would I need to do at this point? Take the square root. Take the square root. Now, normally when I take a square root, it's plus or minus, but I'm talking about a length here. Will a length ever be negative? No. So in this case, I'm just thinking about the positive square root, so I won't even write plus or minus out in front. Do you know the square root of 2? No? We have to leave it under the radical. Do you know the square root of x squared?
Yes.
Yeah, what is it? X. So, this is what we can use for any right triangle. Any isosceles right triangle or 45, 45, 90 right triangle. Whatever one of the legs of the right triangle is, the other one is also. And this shortcut right here, instead of having to go back to the Pythagorean theorem, this shortcut tells us that the length of the hypotenuse is always going to be the length of the leg times the square root of 2. So in this example, if one leg is 8, the other one has to be 8. And the hypotenuse would just be 8 times the square root of 2. Always. On a 45, 45, 90 right triangle, it's x, x, x root 2 is our pattern. Whatever the legs are, you just multiply by the square root of 2 to get the hypotenuse. Pretty cool, huh? So, if that's our pattern, these are our side ratios. If this is our pattern, what would we do to go backwards and find, if we were given the length of the hypotenuse, to find the length of a leg?
Take away the square root.
What would we do to solve this for leg? Divide by the square root of 2. It's the hypotenuse divided by the square root of 2. So I divide by the square root of 2. What's 5 root 2 divided by square root of 2? Yeah, those just cancel. 5. Okay? And that's how that works. All right, let's do a few more examples together. Okay, so on this one, we're given the hypotenuse. And how do I know this is 45, 45, 90? Because it's marked. it looks like an isosceles right triangle. That makes it 45, 45, 90. Which side did they give me? The hypotenuse. So to go backwards and find a leg, we divide by the square root of 20. So what would the legs be? 10. Now, some of you might be like me. You didn't like subtraction and you didn't like division. And in your head, you just always think backwards. Anybody like me? Yeah. I don't subtract. I just figure out what do I add to the smaller number to get to the bigger number. That's the way my brain works. I don't divide. I look at the smaller number and go, what did I multiply it by to get the bigger number? Got a weird brain. Some of you do too. That's awesome. So I look at this and go, hey. I said, hey. I'm watching too much Duck Dynasty. What did I multiply the leg by? I multiplied a leg by a square root of 2 and ended up with this. What was it? And that's how I think. And we'll look at why that's helpful in a minute. All right, here we go. This leg is the square root of 2. What's the length of the other leg? Same thing. Legs are the same. But then the hypotenuse, I have to multiply by the square root of 2. What happens when I do square root of 2 times square root of 2? It's square root of 4, which is 2. 2. Okay? All right, this one's got different markings. Is it a different new triangle? No. It's still isosceles right.
Yeah, I was scared for a minute.
Okay, so if this leg is 3 root 2, what is this leg? 3 root 2. And so I multiply by the square root of 2 to get the hypotenuse is? 6. I get 3 times 2, which is 6. Now, some of you can do that in your head. Some of you will need to write it a couple times before it makes sense in your head. Okay, now, this one, is that 8 a leg or the hypotenuse? It's the hypotenuse. So we have to go backwards and find a leg. So, why does everybody have rulers? Oh, you drew that. Okay. I'm sorry. I just keep watching them spin around like helicopters, and it's distracting for me.
I can't spin mine like a helicopter.
He still has it.
Lauren, all right, so let's take a look at this problem again. So we have 8 is the hypotenuse, and we have to divide by the square root of 2. So, is my answer 8 over the square root of 2? Ta-da!
Oh, that was easy.
Am I done?
No.
No. Why can't I leave it like that? You can't leave a radical in the denominator. How do we get rid of it?
You times by square root of 2.
Multiply by the square root of 2 over the square root of 2. So, it makes it 8 root 2 over 2, which is 4 roots of 2. All right, happy backwards thinkers. When I think about this, I'm going, okay, I got a leg that I multiply by the square root of 2, and it turns into 8. So what number can I double to get 8? 4. So it's 4 roots of 2, because root 2 times root 2 is 2, and 2 times 4 is 8. Okay? So if you're a backwards thinker, you followed what I just said. If you're not, you do this. And you get the same answer. Oh, you don't have to do the little dance when you do it, though. All right. Okay, you try.
Got it. It looks like UTV.
It does.
That's going to make me mad. UTVY.
It's a good. It's UTCV.
I
understand math or what? I did it in my head in 2 seconds.
Okay, did we get 10 root 2? 10 root 2. Any questions? Let's get back up to the top of this half and look at our other fabulous special right triangle. So, we just did 45, 45, 90, and we started out with a square, and we turned it into a 45, 45, 90. Well, this time we're going to talk about 30, 60 triangles, and we're starting with what appears to be an equilateral triangle. So, We have a 60-degree angle, a 60-degree angle, a 60-degree angle.
Yeah.
Got it? All right, so I need to turn this into a 30, 60, 90. So if I bisect this angle,
That was a terrible
by,
discussion.
thank you very much, it's still not perfect. You can make yours perfect, and I can try to be
Well, I
better.
can't make mine perfect. I don't have a ruler.
I did take away the helicopter spinning rulers.
Mine won't. That was only Lauren.
It was
Okay.
only Lauren, makes her
Yeah, you should have just taken it away from her.
Well, it was him before it was her.
No,
Good.
I
He
tried,
was trying.
but it wouldn't spin because it's like the whole.
Okay,
Logan.
so now I've created this fabulous pair of 30, 60, 90s. We're just going to focus on one of them. We're going to focus on one of them. All right. Now, I'm going to let this length be 2x. So what is the length of every side? 2x. Now, there's a reason I let it be 2x. Because when I dropped down this perpendicular, what did it do to this side? Bisected it. So it makes this little part x and that little part x. That's why I started out with 2x. Just prettier. So I can bisect it. All right. So now if I think about just having this triangle, and I'm going to redraw a right triangle over to the side. I didn't need it to look like that. I just needed it to be solid. I'm still not doing a good job, so you'll have to use your imagination slightly.
That's beautiful.
Okay, so this is my 60-degree angle here. So this is this triangle right here. This is my 30. This was where I put the right angle. This is a 2x that represents every side of that equilateral triangle. And when I bisected it, I got a little x down there for this little short side. Do y'all see that the short side is across from the 30-degree angle? And the hypotenuse is always the longest side, and it's across from the right angle. Hypotenuse is always the biggest. So what I'm missing is this side over here. What can I use to find this side?
Reflection.
C2.
Pythagorean theorem. I know two sides of this triangle, and I'm missing this third one. Okay,
But you have to do a
what do you want to call this third one? It's not the hypotenuse.
T. No.
B?
No, B.
B? Okay, we'll call that one B then. All right, so this one can be our A. X squared plus B squared
TZ.
equals C squared. Now, when I square the hypotenuse, I got to square the whole hypotenuse. The 2 and the x. So this gives me x squared plus b squared equals 4x squared. So if I'm solving for b, what has to happen?
You have to put everything.
You have to move this over here, don't you? To move that over there, what do we do? Subtract. Subtract. So we get b squared equals, nope, 4 minus 1, 3x squares. 4x squares, take away 1x squares, leaves us 3 squared x's. All right, now to solve for b, once again, it's a length, so I don't have to do the plus or minus, just the positive. I have to take the square root of both sides.
Your B's look like a 6.
Yeah, it looks like a 6. It's kind of bothering me.
Mine looks like a
Oh, I just made it a 6.
All right, so we don't know the square root of 3, so it has to stay under the radical. But we do know the square root of x squared. What's the square root of x squared? X. So this is x root 3.
Oh, man.
And this works every time. These side ratios work every time. The shorter leg, which is across from the 30, we let x represent that. The longer leg, which is across from the bigger angle, 60, is represented by the short leg times the square root of 3. And the hypotenuse is represented by twice the short leg. So if we know the short leg, we can everything.
made up a number.
I didn't make up anything. We showed the math about why it works. Oh, in these problems, yes. In these problems, I made up a number.
No,
Yes.
like 2x and stuff. Like, do we have to like make up like 2x?
No, this is what works. Tom.
This is a lot easier.
Yes,
Is it?
ma'am.
Is it, Brittany?
When you're solving for B, why do you put the X?
When I was solving for B, I had to have B by itself and everything else had to move. So I was solving for B in terms of X.
Oh, I meant
Guys, right now a student's trying to ask a question. I can't hear anything. Let's try that again.
Okay, so when you're solving for B, why do you put the X on the outside of the square?
I had to move everything but B to the other side. So that positive X squared had to move over to be able to solve for B. All right, so this is what's going to work. So let's look at this one. Do you see the 8 is across from the 30-degree angle? So the 8 is our short leg. Let's look at what we just discovered. If we know the short leg, we can multiply it by the square root of 3 to get the longer leg. So if the short leg is 8, then 8 times the square root of 3 is the longer leg. And if we know the short leg, all we have to do is double it to get the hypotenuse. So if the shorter one, across from the 30, is 8, then the hypotenuse would be 16. And that is the pattern that works every time for 30, 60, 90. Now, we proved mathematically why it worked, but this is what it is. Okay, let's look at the one on the left. Which side of the triangle did I give you? I gave you the hypotenuse. Well, the hypotenuse is twice the short leg. So what would the shorter leg be? 14. And the longer leg across from the 60 is that short leg times the square root of 3. Okay? Well, we showed mathematically why. Okay, so basically what we've looked at are two different patterns. The 45, 45, 90 has x, x, x root 2. And for those of you that like to memorize stuff, see, I just showed you the y part. Now, if you're all ready to the let's memorize this pattern, here's some things that can help you. There are two congruent sides, two congruent angles, and a square root of 2 in a 45, 45, 90.
So it's 2 square root.
In a 30, 60, 90, there are 3 different side lengths, 3 different angle measures, and a square root of 3. So those of you that are already moved past the understanding, you got the understanding, it makes sense, and to the memorizing the pattern, that's what they are. Okay, let's look at these additional examples down here. Did I get them all? I think so. Okay, the 30, 60, 90 could be a little trickier than the 45, 45, 90. You really only have 2 things to find on a 45, 45, 90, but you have 3 every time on a 30, 60, 90. Now this one, do you see I gave you the long leg? It's across from the 60-degree angle. Well, the long leg was times the square root of 3, wasn't it? This is actually equal to x times the square root of 3. That's what this side is represented by. So if we were to go backwards and solve for x, the short leg, what do we have to do? Just divide by the square root of 3. So what would it be? 9. Now, a lot of you can just look at it. What did I multiply by the square root of 3 to get 9 root 3? 9. And then we double it to get the hypotenuse, 18. Okay? the next one. Which leg did I give you? Short leg. What do we do to get the long leg? Whoop, try again, long leg. Multiply by the square root of 3. So it's 1 root of 3. And what do we do to get the hypotenuse? Double it, so it is 2. Okay, next one. Which side did I give you? The hypotenuse. Okay, if I do not give you the short leg, that is always the first thing you find. If I do not give you the short leg, find that first. So if the hypotenuse is 6, what is the short leg? 3. What would the long leg be? 3 root 3. Okay, which leg did I give you? Long leg. You always find the short leg first. So since this is equal to the short leg times the square root of 3, what would the short leg be? 7 over 2. 7 halves. And what do we do the short leg to get the hypotenuse? Double it. 7.
Yeah.
Okay. Next one. Which side did I give you?
Longest.
Hypotenuse. Got to find the short leg first. What's the short leg? 2. What's the long leg? 2 root 3. Okay, next one. I gave you which leg? Short leg. What's the long leg? 9 root 3 over 2. What's the hypotenuse? 9. Okay. Which one did I give you? The short leg. But what did I do? I stuck a radical in the short leg. That's not a big deal, because you guys have already had a unit on radicals. I can't trick you. So, what do we do to get the long leg? Multiply by the square root of 3, so what would it be? 2 root 3 times root 3, which is 6. 2 times 3 is 6. Okay?
I couldn't find 9.
All right, what would the hypotenuse be? 4 root 3. Okay? Next one. I gave you long leg without a radical.
Oh.
Didn't I?
That's me.
So what do we do to find short leg?
Divide it.
Divide by square root of 3. All right. Can't leave it. Got to rationalize. Root 3 over root 3. And this is 12 root 3 over 3, which is 4 roots of 3. Okay, you backwards thinkers out there, you're asking yourself, what did I multiply by 3 to get 12?
There you go.
So it's 4 root 3.
That's what I got.
All right, and then we double it to get the hypotenuse. Okay, the right side is you tries. You're going to get a classwork grade for this today. Not the back. The back is tomorrow night's homework.
Yes.
The right side is you tries. It's right here. Okay, try the right side.
I don't know if this is a 90-degree angle, Scooby. I can't.